subtopics in the laws of indices, which we call the product of indices, which is under the module 2 for this video. And it tells us about that if x raised to power a at the same time is also raised to power b. So what it just trying to say from that angle is that x will be the powers of a times b. In general, if you write x raised to power a or raised to power b, just write it as if it's x raised to power a times b, which it will give us this. So let's try to have some examples that we explain these very well and will make us to get. So let's simplify. Let's simplify some values. I'm coming. Let's simplify. Yeah, simplify. Let's say a. If we were to simplify x raised to power 2 or raised to power 3, we have to rewrite as if x raised to power 2 times 3. So, giving us x raised to power 6. So, telling you that the x, the a is 2, a is 2, and the b is 3. So, we apply the formula to have x raised to power 6. So, in the simplification, let's have another one like b. For example, we have y raised to power 4 at the same time raised to power 2. We can also, before we apply the formula, let's try to do something that will make it meaningful. Like we have y raised to power 4 times y raised to power 4. I believe this is the scale. If you decide to choose only one y from our former law, we add it together to have y raised to power 8. Let's try to use alternative method, which we are the real formula we are using today. That's y raised to power 4 at the same time raised to power 2 will be y raised to power 4 times 2, which will be y raised to power 8. So you discover that the both are the same. So that is telling you that the product of indices law that we are using, it is so general. So let's also have another example. We have z raised to power 3 or raised to power 5 is equal to. So we apply the formula straight. You know, if you decide to say z raised to power 3 times 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 z raised to power 3 in 5 places. In many cases, they might give us z raised to power 3 or at the same time raised to power 25. So that is why the formula, it is highly so important to apply to just say that z will be 3 times 5. So everything will be z raised to power 15. So remember that if you decide to pick only one z, at this angle, we have, if I just pick only one z, and you add everything together, plus 3, plus 3, plus 3, plus 2. This is 3, this is a 6. Everything will now give us, to give us z raised to power 15. So, you know, you get the same answer, but most important thing there is trying to apply the formula to make it meaningful than just using the manual way of solving it. So, and the examples still continue in another form. Like it does not before, we don't have any constant, we only apply z, c. But now we want to apply. Let's see this example. Let's simplify. Let's simplify something like minus 3d square raised to power 3 or square. You discover that there is a minus, a coefficient that multiply d. Now, this bracket is telling you that it affects the both, that minus 3, the 2 we come to is 8, to multiply d raised to power 3 onto all square. So you're able to see that it's because of the minus. The minus surely affect the 2. So you can even put a bracket here. So to make it convenient, let's try to do it manually for we to understand what we are doing. That this square can give us minus 3 times minus 3. So now to multiply, now this square can also be d raised to power 3 times d raised to power 3. So we have, this is plus 9 to multiply d onto 3 plus 3, which will give us 9d raised to power 6. Now, let's also use our reformula now. So we have a minus 3 times minus 3 times d raised to power 3 square. So what we need to do here is plus 9 onto d raised to power 3 times 2, which is plus 9 d raised to power 6. So that is the answer. You're able to notice that they both have the same answer. So that is how we solve a questions under the product of indices that have a coefficient. So let's also have another questions relating to what you're able to have solved. Let's have this. Simplify. Let's say b of that one you have started. Minus 3. You open a bracket here. D raised to power 3 all square. All square. Yeah. I'm trying to rearrange the values. Now we have, remember that the minus 2, the 2 will never affect 3. That is just the meaning. To multiply d raised to power 3 times 2. So, because the 2 can never have, because these 2 affect those in the bracket. So we have minus 3 times d raised to power 6, which will give us minus 3d raised to power 6. So this is the answer. So let's also have another meaningful example that let's say C of where we have the module 2 of the module 2. So we have bracket open again, minus 4 g raised to power 5 or 3. As I've said earlier, that it will surely affect because of the bracket. Let's now try to expand it. We have a bracket open, minus 4 raised to power 3. Now, times g raised to power 5 or raised to power 3. So, you can see that the 3 affect the 2, both the constant, that is minus 4, and the variable, g raised to power 5. So, now, let's continue with it to have minus 4 times minus 4 times minus 4 times g raised to power 5 times 3. So we have minus 4 times minus 4, we have plus 16 times minus 4 to multiply g raised to power 15, which will give us plus 16 times minus 4. So the minus will surely affect to have 64, to have plus 64 onto g raised to power 15. So this is just how it is. So you're able to see the way it is being analyzed. So let's try to solve one example more and end this class by giving you a classwork to do. And please don't forget, make sure you send the classwork to the comment section. But if you like to join this group, follow these channels and send your number in the comment section. So we're able to add it to a group whereby you submit your classwork and we're able to continue developing you more than you believe. So we have the last example to have a raised to power 3 onto b all raised to power 4 as we have been explaining since, to be a raised to power 3 all raised to power 4. Now to multiply b all raised to power 4. So now we have a raised to power 3 times 4 to multiply onto b raised to power 4. So we have a raised to power 12, b raised to power 4. So that is all. So now we need to solve some classwork. So for you to know, maybe you are really getting what we have been explaining since, and make sure you send this classwork to comment sections as I've explained before now. So now the classwork says that simplify the following. So let me write it very well. The following. Now, minus c, bracket open and close, c squared times c raised to power 4 to divide minus c all raised to power 5. So you tell us, try to solve it step by step, so for you not to make any mistake. So number 2, minus onto bracket open d squared on all raised to power 3 to divide d raised to power 4 times minus d. That is all. Yes, just a minus d. Now another one is 3 minus 3 bracket d e raised to power 3 all raised to power 4. The number 4 minus s to the power 3 minus s to the power 4, but minus s to the power 3 all squared. So don't forget to solve it step by step, and add your number to the comment section so you can add it to a group whereby you can submit your classwork. So thanks for watching this video. Don't forget to share this video and subscribe to this channel. So thanks for watching.